本日はですね、NASA ウダーの宇宙飛行センターからですね、ウラジミール・アイラペディア先生をお招きしての講演です。ウラジミール・アイラペディア先生はですね、アルメニア出身ですね。アメリカにも30年以上住んで、現在ですね、NASA ウダー宇宙飛行センターの主任研究員。プロジェクトはですね、太陽のですね、太陽物理とですね、太陽系外惑星の物理、そして若い地球の物理と3つのプロジェクトをやられています。またですね、宇宙生物学、アストロバイオロジーですね、新しい学問の世界的権威でございます。つい先日もですね、NHK スペシャルのスクランブルの番組でも取りされておられます。またですね、大学院総合製造学科のソーシャルイノベーションセンターの特任教授もされておられます。Okay, I introduce.
Yes.
You start.
Thank you. Hello, everybody. Do you hear me well? So yes, hello, everybody. Thank you for your introduction. Inviting me for this public talk. Today, we're going to talk about the probably one of the most fundamental questions that humanity asks about, are we alone in this universe? So this is the question that was bothering people, since the, thousands of years. The people were looking up, they were looking for gods, they were looking for somebody we can relate to, right? And for the first time, now we can address this question not just from the philosophical point of view, but from the point of view of modern science. And we even can build telescopes in order to get some first clues. And today I'm going to give an interdisciplinary lecture, which is going to be, I understand that we have people with different backgrounds, not just in astrophysics or astrobiology or chemistry. It will be very general and friendly lecture, and then I will, invite you for questions.
Okay, can you translate?
Yes, please. Yeah. Right. Thank you.
本日はですね、数千年にわたっての人類の非常に重要なテーマであるですね、Are we alone in the universe? 宇宙の中で果たして人類だけが唯一の生物種が混沌生物なのかという、そういった疑問に対してですね、人類はさまざまな歴史の中でこの問題を修行的なことですね、さまざまな形で解決しようとしていましたが、ついにですね、この問題を科学的に解明する時代になりました。で、我々はたくさんの地方勉強、またたくさんのですね、さまざまな観測を通じてですね、この問題を科学的に、しかも総合的に考える。本日はさまざまな分野の人たちが集まっているツールだと理解しておりますので、できるだけですね、分野横断的にお話ししたいと思います。
Perspective to this question changed, with Apollo mission. When the Apollo 11 has taken this picture, as you can see here, that for the first time, we looked at our planet, from another body. And that changed everything. That showed that our planet is just another rock in this universe. And that means that if this rock exists in solar system, many other systems should also follow this. So I will, and this question actually was asked even before Apollo people. So I want to come with this, the recently discovered document written by Winston Churchill, the Prime Minister of Britain, Great Britain. It turns out that before the Second World War II, he not only asked questions about what is going to happen to Great Britain, when the Great Britain was on the verge, on the war with the Germany, but also he asked a question about, are we alone in the universe? And he wrote 11-page essay that says that with hundreds of thousands of nebula, each containing thousands of millions of suns, the odds are enormous that there must be immense number which possess planets whose circumstances would not render life impossible. So he basically realized that we live in a galaxy, and this galaxy has 100 billion stars, and if each of the stars, if we're not exception, you have also exoplanets, we need to have so many billions of planets. And that was written, as you can imagine, over 70 years ago by Winston Churchill.
イギリスのチャーチル首相ですね、第二次世界大戦の最中やはり失敗したので、やはりそのナチスドイツとの戦いで、私、イギリスのことだということを知っていた。ところがその時にですね、彼は同時に、果たして宇宙で我々が唯一の星なのかどうかということを知らない。やはり宇宙にはたくさんの星があります。1000億の星があると言われています。その中にですね、もし惑星が他の星にあったとしたら、一体どれだけのですね、星が惑星があるかということは、想像にいないです。そんな疑問をですね、実は70年前にイギリスのチャーチル、
Winston Churchill in 1939.
1939年実はあります。
Yeah, so next slide, please.
Okay.
Yes. So I want to follow the the words of Winston Churchill and saying that with this hundreds of billion stars in the galaxy, and start our journey into the life in the universe, with our galaxy, because our galaxy is our home, okay, and our sun, as you can see there, is just one star. You see this? It's in the middle, in the corner. Might be I don't have access to the only. So I just want to show this is the yes, this is our sun, and it's just one dot, and it has 8 planets around it. And it turns out that in this our galaxy we have at least 100 billion stars, and 10% of the stars are every 10th star is like our sun. Okay, with the size, with all this, with all the characteristics. So, and at the center we have a black hole that was recently, discovered and imaged by radio interferometry, and so now our galaxy has its own black hole, the supermassive black hole, and the distance between us and the black hole is 25,000 light years, meaning that if you take a spacecraft and go with the speed of light, you need 25,000 years, to reach the black hole. That means that we are, as you can see, halfway. If you can consider the black hole as a downtown, okay, imagine the downtown Tokyo, it's very busy, right? Like Shibuya area or Shinjuku area. But imagine that, and of course it's very noisy there. A lot of people, they may collide, right? So, but imagine that if you go farther down, if you go to, to Oimachi, let's say, to that's already kind of like you in the city, but you on the halfway to the end. That's where we are, between the end, in the middle. And the question is that astronomers ask, is that required? Is that the coincidental? Is it coincidence, or it should be the case?
我々がですね、どこに住んでるかということをまず確認したいと思います。これがですね、我々の天の川銀河という我々が住んでいる銀河系でございます。我々の銀河系の中の太陽の位置というのはこの下側ですね。このちょうど下側、ちょっと今彼が言ったところにあります。中心にはですね、でっかいブラックホールだということが分かってたんですけども、つい最近、3週間ぐらい前にですね、これが実際のイメージとして、電波望遠鏡の世界中の電波望遠鏡を合わせた、今、イメージ作成で撮動されましたというのは記憶が正しい。そのブラックホールと我々の太陽系との距離がですね、大体2万5000光年です。銀河系の直径が大体10万光年と言われていますが、中心から8個まで5万光年。そうすると、ちょうど中心、我々がちょうど真ん中にいるという考えてもいいです。で、もちろん中心にブラックホールがあるということは、中心部にですね、たくさんの星があって、非常にゴリゴリしています。言ってみれば東京のですね、中心部がですね、たくさんの人がいて、もう人が高い人に疲れる。それをちょっと離れていて、大井町でたかな、ちょっと分かんないですけど、ちょっと要は周辺部にですね、人混みがそんななくなって、静かにすることができる。そういうところにいます。天文学者はですね、これをですね、これは果たして偶然なのか、あるいは必然なのか 要するに我々の地球がここにあって、地球に生命がいるっていう、その地球の位置がですね、あれ太陽系の位置が銀河系のちょうど真ん中から半分ぐらいの距離にあっては、必然なのか、偶然なのか、果たしてこれがどういう意味があるのかっていうことはいつも議論しています。OK。
Yeah, I just want to add to this slide before we end, which is that we live in a very typical galaxy. It's the 3/4 of all galaxies, 75% of all galaxies observed in the universe, and like that, spiral galaxies. And the second one, we live around very typical star, like our sun. It's also very typical. It's basically like you go into the street and find a person, it will be very typical. So that's what we are. Looks like that there is nothing special. That's the first message that we learn about.
ですね、まあ、例えば我々のこの住んでる銀河っていうのもなんか1000億。How many galaxies do you have? 100 billions?
10 to the 11, 100 billion.
100 billion.
100 billion.
やっぱりこのような銀河がですね、宇宙にはなんと1000億個ある。
That's what the Hubble Space Telescope.
ちょっと信じられる。要するに1000億個の星がある銀河が宇宙には1000億個ある。ちょっととんでもないことなんですけど、75% の銀河が、スパイラルギャラクシー、渦巻き銀河、我々と同じ銀河系であるということです。それがですね、また我々がの太陽というのは G 型星というんですけど、これも非常に普通にある星でございます。だから我々が住んでいる太陽系、そして地球、そして天の川銀河っていうのは、宇宙では非常に普通の人、要するに特別な存在ではないということです。
Okay. Next, please. Yes, so this opens the question about if you say that our place in the galaxy. You can see the green ring. The green ring is so-called galactic habitable zone. The galactic habitable zone is the place where we can live. Not in the downtown, but not very far away from the city, from the center of the house. Why? Because if you're close enough, so the black hole creates the radiation, creates these outflows, and this can affect our magnetic field, our magnetosphere, our Earth. And it has many supernova explosions. And supernova explosions can cause danger to our life on Earth. So therefore, if you're far away, it's good. But if you're a little bit farther away, then as you go down, the metallicity, the amount of metals in those rocky planets would be much smaller. And we need carbon. We are carbon forms. So beyond green zone, you cannot find necessary chemical elements in order to build life. If you're close enough, it's dangerous. You have abundance of chemical elements, but on top of it, you have a lot of ionizing radiation. So scientists came up with the galactic habitable zone, the region where we should find the habitable planets.
はい、銀河系のこれがギャラクティックハビタブルゾーンといって、銀河ハビタブルゾーン、こういう定義が、初めて聞いた人が多いと思うんですけど、銀河系の中心はですね、中心ブラックホールがある。そうするとブラックホールに付着するその中に落ち込む物質がですね、いろんな危険な電磁波をいっぱい出します。その電磁波がですね、例えば地球があったとしたら、その磁場を狂わしたりですね、いろんな影響、大気を破壊したり、いろんな影響を与えます。そしてですね、超新星がですね、星の数が多いので、その分寿命を迎える星が多いわけですから、超新星爆発がいっぱいある。超新星爆発っていうのは人間にとって危険なわけですから、あまり頻繁に起こるとですね、困るわけです。だから、超新星爆発が起こる、またブラックホールがある、そういうことを考えると、銀河中心っていうのはあんまり良くないと考えられます。でもちろん、利点もあって、必要な金属とかカーボンっていうのはたくさんあるということです。それに対して、この緑のゾーンから外側のゾーンですね、これは外側になるとですね、要するに超新星爆発が全然メタ起こらないので、いわゆるその金属量っていうのが少ない、あるいはそのカーボン、我々の体を構成しているカーボンが、そもそも存在できない可能性があると。そうするとですね、やはりその緑色より外側でですね、生命が誕生する必要な物質が十分に生成されない。で緑色より内側だと、頻繁に超新星爆発が起こったりするブラックホールがして危険だということで、やはりこの銀河系でハビタブルゾーンというのはこの緑の間にあるということが考えられます。
So what you see here this, the band, right? This red band, and you see the dot. This dot is our so-called, this was called the pale blue dot by Carl Sagan. When the Voyager 1 was coming out, it's the one of the further spacecraft that NASA sent way back in the 70s. And it's already beyond the solar system. It's still going, it's still working. When it was already far away, I think it was in 1990s, Carl Sagan, the famous astrobiologist, asked the NASA to take a picture of our Earth. And that's what you got, this dot. So you saw the picture of the planet from the moon. That was a disk, the Earth as we know. And that's what we're trying to find in this universe. We're trying to find another dot that is actually pale blue dot. And the reason why it's blue, because it has oceans. And the oceans are important for life. So it's the part of habitability. So this is opens up the, that's in 1990, right, by Voyager. Opens up a new perception of what we should look for this pale blue dot.
And what is this red line?
Oh, it's just scattered light from sunlight.
Oh, I see.
So the picture was taken at some angle.
このですね、Voyager の1号、2号、This is Voyager 1 or
One, it says one. Oh, it doesn't. Sorry.
Voyager という宇宙船がありますね。これがですね、無人ですけど、太陽系の今、線路にあるんですけど、1号と2号があって、1990年代に、皆さん聞いたことあるかどうかわかりませんけど、我々の子供の頃よく見たコスモスという宇宙番組なんです。まあ、今でも探せば見つかるんですけど、かなり有名な番組で、その番組が初めてですね、その宇宙の外に生命があるのではないかということを真面目に学者として話をした。まあ、当時何も分かってなかったんですが、そのカール・セガンがですね、NASA にボイジャーから地球を一回写真を撮ってくれと言って頼んだらしいです。それで撮ったのがこの写真で、この有名なペールブルードット、非常に小さな宝石のような青い丸い玉、点です。ペールブルードットっていうのは非常に有名なのですが、なぜ青いかっていうのは、太陽があるんですね。で太陽はどうしても生命に必要だと。これ宇宙から地球を見ると、こういった小さな青い点の粒、宝石のような粒に見えると。これがですね、現在ですね、地球から他のペルブルードットが見つかるか、それ方向に今研究を進めているので、これ大変だなっていうことです。またですね、宇宙の中にこうやって生命のある地球を見ると、こんなふうに見えるんだなということが分かっています。OK。
Yeah, so next slide, please. So now I want to talk about what happened about another event. So we talked about Apollo 11, that was one important event. Then the second event was the Voyager 1, right, when we changed perception. And the third revolution, much bigger revolution, was in 1995, when Michel Mayor and his collaborator, the GM from Switzerland, from Geneva Observatory, they built a spectrograph and they looked at, they thought, let's look at the sun star. And they discovered the first exoplanet around a star in our galaxy, pretty close. Since that time, scientists used a so-called transit method that to basically find now over 5,000 exoplanets. And so this slide shows that how it works. It's a movie. Can you please run the movie?
So you don't talk about the language.
No, that would be enough. Yeah. So yes, please, because Kepler uses the transit. Please, yes. So yeah, please watch this movie, and then we're going to talk about it. That created by NASA about when the Venus transits the sun back to 2012.
Can I translate?
Yes.
1990、次のですね、大きなレボリューションが1995年にですね、ミシェル・マイオールですね、スイスの工 ームさんの向こうにですね、惑星を見つけます。これはペガサスダブルディスタンスに惑星なんですけど、それがテロを書いたわけです。ノーベル物理学者。それはラジオベロシティメソッドですけど、またその後ですね、トランジットというたくさんの惑星が見つかったんです。これは実際に金星がですね、金星の日面通過で、金星が太陽の前を横切った、これ2012年のビデオなんですけど、それのビデオです。要するに小さな惑星が恒星の前をですね、横切ると、こんなふうに見える。これ実際我々も太陽が見てたんですが、それですね、SDO の観測のビデオを今見せてます。要するに、小さな惑星、金星と地球というのはこの2つなんですが、
So in this picture, what you see the transit of Venus across the disk of the sun. And it happens, from time to time. 2012, it could be seen from Japan. And I know many people have observed it using even a small telescope. But this picture was taken by the Solar Dynamic Observatory, with the observatory in space that observes our sun, in the optical band, in the X-rays, in ultraviolet, in different lights. And so you see this is the sun observed in the X-rays. Okay, so where you can see regions with a temperature over 1 million degrees Celsius. It's very, very hot plasma. And because, Japan is the country of the rising sun, so we need to know about the sun. And the sun is very, very important, not only from philosophical standpoint for Japanese, it's important from whole civilization, and looks like maybe important for the origin of life. So using this image, so you can see that the Venus blocks the part of the whole disk, right? So therefore, when you look at the signal, and the next slide, please. It continues the whole idea. We want to see that if the planet can also transit the star, around star, and see this to detect the signal when it transits. And that's how we can find the planet, by its shadow. We don't see the planet, we see the shadow of the planet. Yeah, so this is the movie. As you can see, planet goes around and you see the light, and underneath it goes down, because so it blocks the part of it, right? So the star is slightly less bright than when the planet passes away. When the planet goes away, it goes back to the normal, to its normal brightness. So this is so-called transit method. This is the method that is normally used in order to discover exoplanets. Yes, please.
先ほどのこの SDO のですね、これはSDO、ソーラーダイナミックオブザーバトリー、人工衛星から撮ったやつです。これはですね、太陽ですね、例えば電波、例えば可視光だけではなくて、X 線とか紫外線とかさまざまな形で観測するんです。日本はですね、やはりその太陽のリズム国と言われるので、やはりその太陽に対する意見は非常に大きいと思うんですが、太陽に対する研究が進んでいるとですね、あと太陽をですね、やはり生命に与えるというのが大きいので、そういうことをやっぱり確認するということが今も進められていると思います。それに対してですね、その太陽系外惑星ですね、太陽系外惑星を見つける方法の一つ。今日はですね、時間の関係で非線速の方について話しますが、今最もトランジットというのは、全く金星の日面通過と同じ原理ですね、恒星の前を惑星が動きったときに、この惑星を直接見るんではなくて、光の量がわずかに下がります。これを見ます。要するに、このライトカーブのですね、この今、惑星がですね、この恒星の前を見るときに、光が原稿を見る。この原稿を見ることによって、惑星を探す。これがトランジットという。
So this now you will see the whole diversity of over 5,000 exoplanets that astronomers already discovered. Using the transit method and also using the radial velocity method, it's basically, but that allows you, I'm not going to go into details, allows you to measure the mass, how heavy the planet is. Transit method gives you how big the planet is. So if you know how big it is and how heavy it is, you know whether this planet is a rocky planet or it's a gas planet. Okay, so the density is important. Is it like Jupiter-type planet, or it's like Earth planet or Venus planet? Okay, so now we can answer those questions. And now you see in this picture, and it's a movie. Before we run the movie, I want to explain this. You see here some of those dots are red, and red means that they are very, very hot. Temperature is 1,250. It's a lava planet. And the blue, it's like our Earth, a little bit cooler. And you can see that each one, the planets are revolving around the stars. So this is basically each one of the solar systems. So many exoplanetary systems. And this is our solar system. This one, ours, and also small. Each one of them are most of the stellar systems, as we can see, they're very, very compact. Our solar system is pretty large, but it's not typical. Most of it, we find that planets that are very, very close to their stars. I'm talking about close, 20, 30 times closer than the Earth. And actually speaking, that was discovery. Before Michel Mayor discovered these exoplanets by radial velocity in 1995, two American scientists from the University of California, Berkeley, they observed it with the same kind of spectrometer that Swiss astronomers had, and they discovered that it should talk about which is like a Jupiter-like planet, very massive, but very, very close. Basically at the distance 100 times closer than Jupiter in our solar system. And because we only know about our solar system, he asked a question. He said, oh, it's impossible. It cannot be a planet because Jupiter cannot be so close because our Jupiter is so far. And because of that, imagine that people should have open mind. So the nature has so many surprises for us. And if we can basically follow the traditions, that's because we know that, we cannot make discoveries. And so they missed the Nobel Prize. But during the Nobel speech, they showed the picture presented by Marcy and Butler, the American scientist who first discovered the first exoplanet. Butler, Marcy and Butler.
So you have a name?
Jeffrey Marcy.
ですね、これは現在ですね、太陽系学生の5000以上見つかっているんですで、このムービーはですね、いわゆるその太陽系学生が、ここは太陽系なんですけど、それに比べてどんな感じで回っているのかっていうのをイラストに描いたやつです。赤いやつはですね、非常に熱いイメージで描いておりますが、青いやつはですね、今度はそれほど大きさもですね、地球サイズのやつから木星サイズのやつ、いろいろあります。で、先ほどの話はですね、2019年のノーベル物理学賞のミシェル・マイヤーですね、51ペガスペガスなどの一番星を見つけたときに、地星の子供というものをですね、見つけたんですが、その木星サイズの木星の2倍あるその惑星がですね、恒星の周りを非常に速い速度で4日で回ってたんですね。で、それを見つけて、それをですね、ジェフ・マーシーというアメリカ人のですね、バークレーの教授もやっぱり見つけてたんですけど、いわゆる太陽系の生成理論では、そんな近くに木星があるはずないと。間違いではない。彼はその惑星だと思わない。それをですね、ミシェル・マイヤーがちゃんと惑星だとめっちゃ出して、それが認められて、ノーベル物理学賞だから、ジェフ・マーシーはですね、残念ながらノーベル物理学賞を逃したんですが、そういう感じで、この概念があったがためにですね、彼は第一発見者になったというこういう話ですが、なかなかやはりその新しいブレイクスルーというのは非常に大きな今までの常識を完全に覆すことが起こったと思います。
OK. Next slide, please. So what you see here, it's the telescopes called Kepler Space Telescope. It's a telescope much smaller than Hubble Space Telescope. Okay, it's only 90-centimeter telescope, and very, very cheap mission, NASA mission. And so the principal investigator of this mission basically build the prototype in his garage. NASA didn't give him money unless he could prove that that will work and the planets can be discovered. And then was happened to be one of the most successful missions in the history of our civilization, because imagine what this telescope did. You see here the Kepler field of view. Imagine that for 4 years, you look at one part, in one part of the room, and there is many objects there, and some objects change their light. But imagine that you look at this part only day and night, 4 years, every single second. That's exactly what Kepler did over there, like nine years, from 2009 to 2018, the mission retired. So, at each pixel, it's like one star. They observed 150,000 stars. And they looked at the life of the stars second by second. So we got a lot of information about stars. We discovered super flares. So Japanese astronomers contributed, Maehara contributed, and Shibata-san's school contributed to discovery of super flares. That was one discovery, but the discovery of exoplanets, it changed our understanding. So that's why I call it revolution. Because now that we have several thousands of exoplanets, and people are discovering every day 10, 20 exoplanets. And so that's how we discovered that some of them are big, some of them are small, some of them are intermediate. For instance, we found that on our solar system, we have planets like Earth, okay, or a little bit smaller, like Mars. And we have planets that are 10 times bigger than Earth, like Jupiter. Okay, and then we don't have anything in between, either like Earth or 10 times bigger like Earth. And then we just found, using the Kepler data, we found a new type of planets called super Earth. So super Earth has a size, it's like 3 times bigger than Earth, 5 times bigger than Earth. So basically, something that we don't have in our solar system. And it turns out that it's a lot of exoplanets have exoplanetary systems have those super Earths, but we don't. So now we don't understand why. Might be it doesn't have anything to do with habitability, or it doesn't. But this is another discovery made by this great Kepler space telescope.
Okay. ケプラー宇宙望遠鏡というのはですね、ハッブルに比べて非常に小さな、直径90センチぐらいの望遠鏡です。で、予算もですね、非常に限られていてですね、ちゃんとした試験機を作られずにですね、そのまま宇宙で行ってミッションを行って2009年から2018年、9年間動きました。このケプラーがやったのは、この今見てるジョーダンとですね、ここにケプラーフィールドっていうのがあるんですけど、このエリアはですね、昼頃よりもずっと休まずに9年間光、ライトカーブを飛び続けました。観測された星は15万個と言ってますけど、私は20万個になっています。で、これがですね、結果的に2000個以上の系外惑星を見つけたんですが、その系外惑星だけではなくて、日本人の研究者、柴田教授ですね、教授と前原さんも来週来るんですが、彼らがスーパーフレアをですね、見つけました。これはネイチャーに2012年に出た話ですが、それまではスーパーフレアでは知ってない。そういう意味ではですね、やはりもうたくさんの数の惑星が来ました。今でこそ毎日10個ぐらいの系外惑星が見つかっているんですが、こういった系外惑星を大量に使うという、こういう状況がですね、もたらしたのはケプラーです。ケプラーはですね、また全く違うタイプの惑星を見つけました。それはスーパーアースです。超地球というかスーパーアース、地球の3倍から5倍あるんですけど、岩石惑星があるということを
Next slide, please. So one of the amazing discoveries that Kepler Space Telescope did, it found a planet like Earth, size like Earth and the mass like Earth. It's called Kepler 186f. So this was the first Earth-like planet found back to 2013 using Kepler data. And you can see that the lower the picture shows the solar system with Mercury, Venus, and Earth. Okay, and the Earth is at 150 million kilometers away from the sun. So what you see there, the Kepler 186, it has 4 planets. So we have 8 planets. This has 4 planets. And see that the closest planet, the farthest planet, sorry, is at the size, at the orbital location of Mercury. And the closest planet, it's about 20 times closer than Earth from the sun. So because the star is not like our sun. Star is much cooler, twice cooler. So it's a very dim star. So therefore, if you want to, heat the planet with starlight, you need this planet to be close. Otherwise, it will be an icy ball. So that's why so-called habitable zone for the planets depends on how powerful the star is. If the star is hot and emits a lot of energy, then of course you want to be at 1 AU at distance 150 million kilometers to receive amount of energy in order to have temperature like today in Kyoto. But if you go farther away, it will be too cold. It will be a icy ball. If you come close, like a little bit close, like Venus, let's say, okay, then you will be very, very hot. Temperature is over 500 degrees Celsius. So therefore, and water cannot exist there. So this planet was found, and you see green, in the habitable zone. The zone, again, where it's not very cold for the liquid water to exist, and not very hot to have the hellish conditions that where life cannot be present. So this is habitable zone was discovered on this by Kepler mission, and since that time we have discovered so many exoplanetary systems with habitable zones. So that's how the question of habitability started, appeared in the scientific literature, saying that can we find exoplanets that that receive not too much energy and not too little energy, just the right energy, that so-called Goldilocks zone, that is required for water to be present. And why water? Because water is the great solvent of life, and it's also a great regulator of our climate. Okay, thank you. Please. Yes.
ですね、ケプラーが発見した、最も偉大な発見というのが、アナザーアース、地球に非常に似た大きさを持って、かつ地球とよく似たおそらく祖先を持ったであろう惑星を発見した。これですね、2013年に初めて発見したケプラー186という惑星です。ちょうどですね、サイズが地球相当があります。ただ違いがありまして、中心線がですね、これ K 型線です。M1 かな。This is M dome.
Yes, M dome.
This is, I found the spectrum in K, the spectrum type is M1.
It doesn't matter, it's a cool star. That's what the.
Yeah. で、このケプラー186というのは、要するに中心線がですね、太陽より小さいわけですから、暗いわけですからですね、この図で分かるように、もっと近くもあるんですね。ちなみにこの惑星はですね、一周、1年が129日です。地球の365日くらい近いんですが、こういった形でですね、中心星が、暗いとですね、それだけ近くに寄らないと、ハビタブルゾーンに近寄ることができないということです。だからですね、我々はちょうどこの、ハビタブルゾーンとかですね、ゴルディロックスゾーンというんですけど、いわゆるちょうどいい光を浴びる領域っていうのがあると。そのゴルディロックスゾーンに存在する惑星を発見しようという話になるわけですね。で、そのゴルディロックスゾーンというのは、ちょうどその星から出る光とですね、あとその惑星のサイズ、星の体力、いろんな要素になるんですが、一番大事なのはですね、要するに生命を育む、我々の知っている生命を育む、いわゆる水の存在、海洋の存在ということがある程度保証されるということが要点になります。
Yeah, so next slide, please. So what you see here, that's another great system that Kepler found, the so-called TRAPPIST-1 system. It's pretty close to us. So if you have a spacecraft and which moving with the speed of light, it's only about 39 years, to get to that system. It's not that bad, right? So you can get there in your lifetime. while to the, so as I said, supermassive black hole, it takes 25,000 years, but here it's only 39 years. So what you see here, the TRAPPIST-1, it unlike Earth, it has 7 planets. So pretty close, like we have 8 planets, this has 7 planets. What's interesting is that unlike our solar system, all 7 planets have like our Earth. They're all rocky, they're all small. We don't know how they form, but there's all 7 planets, and you see the green light in TRAPPIST-1, so-called habitable zone. 3 planets are within this zone that they receive enough energy from the star, the center star. You see the red star. It's again, it's so-called M dwarf star. It's very, very dim star and very, very cool star. Twice cooler than our sun. The temperature is twice less. So that's why it appears like a red. And because it's small, we call it dwarf. It's a red dwarf. Okay, so the red dwarf gives away its energy, making the planet E, F, and G as the 4th, 5th, and 6th planet to be habitable, meaning that generally the conditions are okay. Okay, so yeah, and again, the closest planet is 100 times. Yes, that's right. The closer, the 100 times closer than the Earth to the Sun. 100 times closer, very, very close. And the further one, it's at a distance of 0.06 AU. So and that's the interesting system. And the James Webb Space Telescope that they're going to talk about today will have this. Will try to observe E and F to the stars to see that, because some of the people believe that there might be happening. But unfortunately, for instance, our models suggest that probably it's hard to expect any thick atmosphere there. It will be like Mars, that has very, very thin atmosphere, if any. So yeah, future observations gonna test this case and see that, whether our theories are correct or not. That's how science works. We make predictions and then we test those predictions.
これはトラピストシステムという惑星です。トラピストはですね、7つの岩石惑星があります。距離がですね、地球から39光年で、さっき銀河中心までが2万5000光年というのは39光年だったら、まだ皆さんいけるんじゃないですかというので、おすすめです。で、一番近い惑星の B はですね、0.01 天文単位なので、ちょうどですね、地球太陽間の距離100分の1ぐらいです。一番遠くはですね、0.06 天文単位なので、ちょうど100分の6ぐらいです。非常にだから、もう中心星がですね、そもそも、温度が2500ケルビンしかなくて、非常に暗くてですね、要するに、これだけ近くに行かないとハビタブルゾーンではないという。ついでに言うとですね、固定周期もですね、2日とか3日とか、それぐらいで回るんです。で、非常に地球サイズの惑星がたくさんあって、非常に有名な星球ではあります。で、特に E とFはですね、ハビタブルでないかということで、次のですね、もうすでに打ち上がったジェームス・ウェブ宇宙望遠鏡です。観測対象になっています。ところが、私が思うにですね、実は中心星からの紫外線によって、おそらくこれらの惑星には十分な大気が残ってないのではないかと私は考えていますが、こういったことをですね、ジェームス・ウェブ宇宙望遠鏡でですね、明らかになるでしょうということです。Okay.
Next slide, please.
So,
yeah, so what you see here, you see the picture of the sun, of the TRAPPIST sun, from the planet, from the habitable zone planet. You see that how big it will be because the star is so close to its planet, and so it should be probably still, it has some ice. If atmosphere is available, then it may have water, but we still don't know is it habitable or it's bare rock, and so we'll stay tuned. Just in about 6 months, we will know from observations where they're going to observe any signatures of the atmosphere. It's like on Mars. Martian atmosphere is 100 times thinner than the Earth's atmosphere. Because it's 100 times thinner, when the water bursts out from the underneath of Mars, it immediately evaporates. It doesn't stay as a liquid water because the pressure is very, very low. So that's why today Mars is a dry planet and it's inhospitable planet. And they're going to talk about Mars soon. But that's basically the one question that we want to ask soon and have the answer this year.
トラピストンですね、この大気が今私が考えるに非常に薄くなっているので、要するに大気があればですね、水を保持することができるんですから、例えば火星の大気圧というのは地球のこの位置でほとんど薄いので、水はですね、液体の状態で保つことができないので、液体になろうとすぐにしてしまうという状態になります。果たして大気圧が十分にあるのかないのかというのが、実は惑星がハビタブルかどうかということの結論で、おそらく今年、例えばトラピストについては結論が出るのではないかと考えています。Okay.
Next, please.
Yeah. Can you accelerate?
Yeah. So, the second half, I want to say about that's one way to look for life outside, right, in the outer space. Another thing to look in our backyard, in our home, in our solar system. And Mars, it's one place. So, the Mars also shows recently, just about 2 months ago. So we have, this Curiosity rover, a machine that basically travels on the surface of Mars, built by NASA, Goddard Space Flight Center. And so this Curiosity, you see this rover. This rover just looking at, he's drilling a little bit, and it has this, sample organics at Mars, so-called this laboratory. Just it grabs the part of the soil and then puts into that chamber and then heats to 850 degrees Celsius and then looks at the composition. And what they found the enrichment of the carbon-12 rich organics. Life on Earth uses the carbon-12 atoms to metabolize and nourishment for photosynthesis. So any kind of life uses carbon-12 with respect to carbon-13. That's another isotope. Okay, so what they found recently, they found those kind of this kind of minerals. They have very, very rich carbon-12. And there is a way probably to explain. Science doesn't jump to the conclusions, but that's a very interesting case that probably tells us that about the past life on Mars.
これはですね、火星のですね、キュリオシティローバーの一種です。非常に高いわけですね、火星の質を調べているんですね。C12、いわゆるその生物の、代謝にですね、必要なカーボンが非常にたくさんあるんです。また、このC13という体もあったんですが、こういったその遺体比からですね、もしかしたら火星というのは生命ですね、適した物質はあるのではないかということが分かりました。Okay.
Yeah, so it also found the water already, the signatures of water on Mars. So now that you have water and you have some conditions, so that presents pretty good case for habitability. So can you have next slide, please? So we are also trying to use Mars for terraforming, because if something happened to Earth, we need to have a place to escape. And so it turns out that not only NASA is thinking about it, and also Elon Musk thinking about it by himself, and is trying to help and cooperate with NASA. So the one way to the terraform, meaning that to make Mars livable, increase its temperature. Mars has a lot of carbon dioxide, and carbon dioxide is a greenhouse gas. So every time we have global warming on Earth, because we are polluting the planet, right, with the carbon dioxide. But what we need to do, we need to pollute Mars with carbon dioxide. It has a lot of carbon dioxide, 96% of the planet is carbon dioxide, but we need to increase it because it receives less than twice less energy from the sun than we are, because it's farther away. And we need to increase it a little bit. If we can somehow increase the temperature by 4 degrees, then the carbon dioxide will be starting to evaporate. So we have a lot of carbon dioxide and water in the poles of Mars. So we need to increase the temperature. In order to do that, we need to stop the atmospheric escape. Mars has very thin atmosphere, very low gravity, and so therefore the solar wind makes and radiation makes the atmosphere escape. So therefore, the one way that we want to do it. Next slide might be we can escape might be the next one, and then I come back to this. Yeah. So we're basically recently made a study, was published about the terraforming Mars. We're trying to build the Mars doesn't have magnetic field. We do have magnetic field. Magnetic field shields the planet from the gas from the atmosphere to escape and out of space. Mars doesn't have it, and the atmosphere gets escaped at the rate of at least 200 grams per second. So now we're proposing to use Phobos. The Phobos is the closest satellite to Mars that will be visited by Japanese JAXA mission actually very soon, and study and bring the research soil research return back to Earth. But if we use the Phobos and inject particles around the orbit, then it will create electric current, and electric current create magnetic field. So in that paper, we explore this possibility how to build the magnetic field and the shield Mars from the escaping. If you do that, in about 50 years, the atmosphere will become thicker. If it becomes thicker, the temperature will go up, and then carbon dioxide will start to evaporate. It will become even more thicker. So it will be like runaway effect. And so that opens the possibility that we can have, and can you go back, please? Slide back. Yes, this one. So you can have, from on the left, you see the red planet. It's a dry planet, inhospitable planet, and cold planet. So the step by step, we can go to the next one. We can already see that it's going to be less redder, and eventually we can have a planet that has water, liquid water. For that, we need to make the atmosphere, which will be less than, thicker than 1% of the Earth atmospheric thickness. If we make it a little bit greater than that, then water will be able to exist, and water also will evaporate. So that's very, very important if we want to colonize Mars, if we want to live on Mars. And so that's what basically the future plans. And we're going to have a mission in 2033, the first mission, trying to start building a base on Mars and proceed from the inhospitable dry planet, cold planet, all the way to planet like Earth. Maybe it's not going to be like Earth exactly, but it will be like, the conditions like when you go to Everest, Mount Everest, something like that. That's my Mount Everest conditions, it will be achievable. But people can live, can eventually, next slide, please. Yeah, let's say. Yes. Yes, yes. Sorry.
火星をですね、テラフォーミングにやはりこの気圧が少ないという問題と、CO2 がもっともっと必要だということです。地球ではですね、CO2 が悪者になってですね、CO2 を特に出さないようになっているんですが、火星はどんどん CO2 を出してですね、温室効果を高めないと、まずそもそも水が溶けない。またですね、例えば4度気温が上がる、火星の気温が上がるとですね、火星のドライアイスが蒸発してですね、CO2 がどんどん出るので、温室効果が進むということが分かります。ところがですね、それだけではダメなんです。我々はですね、特に一番大きな問題は、地球には磁場があるんですが、火星には磁場がない。彼はですね、なんと人工磁場を計画している。人工磁場の発表はですね、ここでも何回かやっていただいているんですが、今回はですね、火星の衛星フォボスを利用した実験。フォボスを利用してですね、いわゆる可燃粒子をですね、こう流して、それによって、電波を引き起こして、電波と磁場を引き起こして、火星をですね、磁場によって守れて惑星です。それすることによって、太陽風による火星大気の散逸を防ごうと。ここまで考えている研究者はおそらく世界には他にいないということです。でそれによるとですね、火星はですね、そのうち温度が上がるとどんどん大気が熱くなって水の存在が可能だと。こういう話です。
So next one, the next one. Yes. So now I want to give a good news. So the one of the might be not very good news was about TRAPPIST-1, that it probably will be a bare rock. But we recently found the next mission after Kepler retired. We had another mission, so-called the Transit Exoplanetary Survey Satellite mission, so-called TESS. And the TESS mission, it's also the NASA and MIT mission, Massachusetts Institute of Technology. We already discovered, the over 1,000 planets. And so it discovered a planet like Earth. And this planet is pretty far away, not like 20, 30, but only about, 16 times farther away, 15, 16 times farther away. And this planet and the star around this planet is very dim. So after calculating how much ionizing radiation it can have, so we found that this planet can be habitable. So it can have the thick atmosphere still. Therefore, we need to explore this spectral signatures that they're going to talk about in my last slide of this planet, so-called TOI 700b. Sorry, you changed this. No, I just want to. Okay, yeah. In order to, we will look for the spectral signatures. What this picture says, if you don't want to translate.
ケプラーなどのですね、非常に重要なミッションで、テスというミッション、これは MIT とNASA がやってるんですけど、テスミッションですね、我々がアイルビデオさんの研究者たちが TOI700 というですね、ハビタブルな惑星を発見しました。この惑星はですね、非常に中心線がおとなしいので、トラピストに比較するとハビタブルな可能性が非常に高い惑星です。そういった星をですね、このスペクトルを見て実際にハビタブルかどうかということを一生懸命観測中でございます。例えば、地球のスペクトルを見ると、こういう物質が見えるんですが、これをいわゆる例えば地球望遠鏡で見ると、一体どういう物質なのかということが分かる。OK。
Yeah, so this is the spectrum of our planet, taken by the spacecraft, and then taking as one dot, like a pale blue dot that I showed from the beginning. That's the composite spectrum. You see, this is the absorption of the light as it passes through the atmosphere of our planet. And you see those deep, created by gases like water vapor and the carbon dioxide. And then you have, ozone. It's O3. It's right here, ozone. This deep, it's ozone, very important for us. This is water vapor. This is carbon dioxide. So those gases are so-called the biosignatures, markers of life. So if we find something like that, we will discover a planet as we know, with a life as we know it. And that's the next step. In other way, next slide. Maybe you can translate both of them because we're already close.
例えば、これは地球を他から見たスペクトルですけど、例えばオゾンの水とかですね、特定の周波数で吸収線が見える。これをですね、他の惑星で発見したいということを考えています。
Yeah, so another way to discover the habitability is that there's many stars around these planets expose flares. And so basically when those flares hit the atmosphere, they can create the additional absorption lines, very deep one, that we will be able to also identify. So therefore we're developing models, theoretical models, how the star on the left interacts with the magnetic field of the exoplanets like Earth, and what kind of signatures it can create during the flares. That's another approach to find habitability. And next slide, please. So yeah, so this year, James Webb Space Telescope, the biggest telescope, on our planet, like 6.5 meter telescope, which is 100 times more powerful than the Hubble Space Telescope. We'll be able to look at this year. This is all those objects, the deep field, the galaxies, stars, and exoplanets. You can see TRAPPIST-1b and E, two exoplanets that will be studied this year. And also Jupiter, Saturn, Titan, Uranus, and Neptune. So this is our next mission that will make probably revolution in our understanding, and young people are really lucky that they are basically participating in the exoplanetary studies and astrobiology.
So I think we should see this.
Yes, and the last time is the conclusion.
Okay. 今年からですね、ちょうどジェームス・ウェブ宇宙望遠鏡が立ち上がるんですけど、さっきのトラピスのですね、アイカンの の世界を背負うことがあります。これは直径 6.5 メートルですね。地球の半分の100倍アウトだとなっております。水が下がるんですけど、これはですね、例えばこれらが起こったときに、その惑星と磁場がどういうものかってどういうものが発見されるかっていうこの意識と、やってます。で、それとですね、このジェームス・ウェブ宇宙望遠鏡を使えばですね、他の惑星にそのいわゆるバイオシグネチャー、生命の痕跡ということが分かる可能性があるということで、これからどんどんですね、他の惑星の生命、他の惑星の生命が分かる。
So my last message is that stay tuned for amazing discoveries coming soon. So we either going to find the bacteria. That's probably our universe is teamed with life in terms of the simple bacteria. Some of them are friendly, some of them might be less friendly, but this is what our Earth as a planet was teamed with life for the first, at least 2 billion years. It was very, very simple life forms, very boring life. And only recently, we got the complex life forms. So aliens versus bacteria, let's see what will happen. But the NASA now has the approved program to look for the signatures of civilizations also. But I personally prefer and think that, we have a good chance of finding bacterial life. Stay tuned for the discoveries. Thank you very much for your attention.
ありがとうございます。ですね、今年から生命を発見するということで、バクテリアのいくつかは人間に有用ですけど、人間に対して良くないバクテリアがいますが、これは宇宙に使うだろうと思います。あるいはですね、我々以上のですね、エリアが見つかる可能性ももちろんあるということを言っています。果たしてどっちが先に見つかるでしょうかということで、これからですね、中生物がですね、これから我々のですね、一緒にご期待ください。どうもありがとうございました。ですね、いろいろ質問したいんですが、アイロメディア先生はまだしばらくいらっしゃいますので、また捕まえて見つけていただければと思います。それでですね、大変申し訳ございませんが、このままオープンキャンパスに入ってよろしいでしょうか。あるいはどうしても休憩が必要ならしますが、このままよろしいですか。よろしければ、ですね、一応じゃあと3分後に始めさせていただいていいでしょうか。はい。じゃあどうもありがとうございました。Thank you very much.
Thank you. Thank you. And last message, I will say that hopefully I will visit Kyoto next year and present the whole course of astrobiology, where we're going to talk about for the full semester about a little bit deeper, how to find life, what the life is, and how to find it. Thank you.
今年の来年3月にですね、上京大学新生中継の本当は今年あるはずなんですけど、そういう宇宙生物学のしっかりしたコースですね、企画中で、これがちゃんと実現することをよろしくお願いします。どうもありがとうございました。Thank you very much. じゃあ、OK, thank you for your presentation.
Thank you.